Cool. Hi, everyone. My name is Narmada. Thanks today for joining this talk show, Lightning Talk. Um, Today, I'm here to actually share my learning in system design and also mainly focus on giving an understanding on how design concerns can play a crucial part while you're making some of the key decisions when you're building any system. So before we jump into the serious part, a bit about me, like just being introduced. I'm currently working as a tech art delivery manager in Accenture, Australia. I know that sounds a bit mouthful, but what I really do is I lead the integration space for a health and public service project. So in addition, I also volunteer for Women Who Code, mentor for Tech Girls Women Foundation. If anyone is interested, there's country registrations open if you want to do some mentoring. I have actually moved to Australia in 2012. It's been a while. I moved to do my master's in IT in Bond University. A lot has changed since then. I have two kids who keep me a lot busy because my eldest is 5 years old and my youngest, he is 2 years old. So quite very engaged. They keep me lots of busy, and when they don't, I like to go with some of the hobbies I listed there. After I returned from my maternity leave, I did a couple of certifications just so I can gain back that confidence. And the first one I did is actually being a professional Scrum Master, and I did two certifications in AWS. The latest is being the Solution Architect Associate. Like I said before in the chat, I'm currently preparing for Solution Architect Professional. If someone is looking for, a study partner, I'm open for that. Let's now jump into the serious part. Before we do a deep dive into understanding design concerns or what exactly they are, it's important for us to actually understand what is system architecture, right? I have been actually designing systems for the past 8 years, and I have come across quite a lot of definitions, and each suited for the company I have been working for. But out of all, there's one which I have found from CBOK, more or less covers everything, wraps up everything. It says like this, like it says system architecture is abstract, conceptualization oriented, global, and focused to achieve the mission and life cycle concepts of the system. It also focuses on high level structure in system and system elements. Now, there are a lot of words for you to actually understand what exactly it means. To simplify, I would say we're trying to define system in a way where we are putting a more fundamental and unified structure in terms of system elements, interfaces, processes, constraints, and their behaviors. Now, when you define all these and document them, that becomes your systems architecture. And each of these behaviors are usually defined based on how each individual element in your system works. Now, I said system elements. So does that mean system architecture is going to focus on just software or just hardware? That's one burning question I always often be asked by the beginners. Now, I'll assure you it actually covers both. There's usually your software architecture, but you also have to, your system architecture is like a composite of both software and hardware. So let's take an example. Let's say you're trying to do a system architecture for an ordering system. So if we are looking at an ordering system, the first thing which comes into our mind is your web front end. You have a business layer service and you have a backend database. That's the most simple architecture you can think of, right? There itself, you have divided the system into 3 different elements, and each has its own constraints, requirements, and how they interact with the other system. Now, that's what you will be defining in your architecture at a high level, but also will be diving deep into some of the decisions or selections you'll make on how those systems should behave or what systems you're going to choose. Yep, so we understood like what we're trying to build up in a system architecture, but why should we actually do it? That's again a question we need to address before we look into actually doing the work, right? Before we start designing any system. Understand this, that system architecture, your document can actually be provided as a powerful tool for all your teams that are working to build a system. because what it does is it provides a common language that can be understood and represents multiple views of all your teams. Let's take our previous example of the ordering system. Uh, Assume we are given a requirement that the ordering system should handle 1 million transactions per second. And that's been known from the start, right? And when you're designing your system, you'll, in a way, try to actually engage with the SMEs from your infrastructure team, your backend team, to come up on an agreed approach how you're going to build that system. And that's how you design it actually. It's not often as thought, an architect role is not a one man's job or one woman's job, but more or less, it depends on how you're getting your information from all the SMEs relevant to the system. Now, we just talked about like how we engage with multiple SMEs before we design a system. So there itself, we are indicating that there's a planning that involves when you design your system. Now, what are the steps that you need to take when you're doing that? The first step I would say is, before even looking into the requirements, is to understand what is your current as-is architecture. Is it a new system you're trying to build, or you're trying to upgrade an existing system? What are the pain points? What are the functional requirements? What are the technical requirements? You need to understand the why you're doing it, what you need to do, and how you want to do it. There will also be a part where you need to look into the stakeholder concerns, because that's where usually the why answer is actually covers it, like why they are doing it. Are there any pain points with the manual processes that they're currently following? What does it involve? What the manual process involves currently? So those are some of the concerns that you'll try to grab from your client, but not always the information is readily available or given openly. It's sometimes implied, even though the requirements doesn't state them, it's implied that you build a system that covers some of the unknown assumptions. And that's where I think design concerns will play a crucial part, because when you look at the design concerns and think, okay, I'm covering off all this, in a way, I'm making sure I'm providing a 360-degree angle for the system I'm building. Now, there's always some, this should always be in the back of the architect, and a rule to find out the known and unknown assumptions. Yep. Now, we just said design concerns that we need to look at, right, before we build any system that will actually help you to uncover any unknown assumptions or your stakeholder concerns that are not clearly stated. What are they and how will they help you? So this is how I divide the design concerns. Scalability, how many users or transactions should the system process concurrently? Performance, how fast does it respond? What's the max throughput? Recoverability, how does the application recover from a fault? Does it take 1 hour or take 1 minute? So those are the things that will actually drive out or help you make some of the key decisions in making sure you're choosing the right system elements when you're building your solution. Security, often this, trust me, it's usually not stated in requirements. It's implied that a user should be able to do this and not this, but it's again it's an unknown assumption made by the client that your system will be able to sustain attacks, your data will be protected. So, and also it's with the latest privacy laws that's been introduced and everything, it becomes our responsibility as an architect to question, are there any requirements on how many days we have to retain a particular set of data? Or should we even store user data or not? So those are the questions you can actually ask when you're looking through each of these design concerns. Maintainability, how easy is it to maintain? We just build a system, right? But then we don't look into the future when we do the handover. Can the client actually do the updates by themselves, maintain that system on an ongoing basis? What's the cost involved? So operability, how easy is it to use? Now you wear your design thinking hat and think about user interactions. What would the end user do? How should it be operated? So all those things will be covered under our operability. availability. Is it available 24/7, and is it 99.9% available? So answering these questions will help you to even uncover the non-functional requirements that are usually assumed. Now, in addition to what we just covered, this is something I have learned this year. And when I look back, so every year, Accenture Fjord releases trends, latest technology trends. And this year, when they have released, there's one particular trend that has caught my attention. That is the end of abundance thinking when we are designing systems. It may apply more to supply and change sort of processes, but having said that, I found that it's equally applicable to any system that we design and might provide some additional value to the systems you're trying to build. Affordability and sustainability. Like, yes, when I say abundance thinking and then say we need to introduce affordability and sustainability, it might sound odd, like looking at this cloud computing, latest technologies, there's infinite and bottomless computing power that's being provided. But having said that, if we are thinking about being a responsible business, it's important that we play a crucial part in tackling climate change and how we can actually help meet the net zero carbon emission targets. So when you're building a system, making sure like if there is a downtime, can we actually turn off our EC2 instances? Does it save? It's also saying it's saving computing power. And we're also making it can also make sure that you're reducing your net zero carbon emission target, meeting your carbon emission targets. So those are some things you can actually think of while building the system. Now, another statement that was given in that article that caught my attention is that when we're looking at affordability and sustainability, we think of innovative ways. And often we think innovation as a way of something new. That's something we have to decouple. Innovation doesn't mean it's new. It can be also something where we're trying to reuse existing systems or bring out more value from existing systems, how we can add additional value from existing systems. So when we are looking at our design concerns, if we can add these additional two as well, I think we'll be able to provide an overall rounded solution that covers all aspects of the system and in a way provides more additional value to the client. Now, let's dig into a case study. Like I said at the start, I have done 2 certifications in AWS. So I was more interested in actually doing a case study on AWS architecture using AWS services. So it's more a very high level statement, doesn't have enough requirements, but we'll make our assumptions as we build to the solution architecture. So we're trying to build a highly available and scalable WordPress site, deploy it on AWS. That's our target. And I'll walk you through the solution architecture I have done. Now you can look, this is how usually the system architecture diagrams will look like. At a high level, you'll have your end-to-end architecture, end-to-end systems detailed out. It shows the arrows with the process, with the data being flown through from one system to another system. Is the data being bidirectional or not? So those are some things that should be notated in your diagrams. And equally, the numbering will also help any user going through that architecture, how the data flows, where is the starting point and where is your ending point. Now, my requirement is actually said like it needs to be highly available and highly scalable. So straight away, I'm thinking multi-region, multi-AZs. So I have a multi-region and then I'm diving down into a single region here, how I have my multi-region setup. Have an Amazon Route 53, which is a global service that routes requests to different endpoints, which can be in different regions as well. So that's what I'll be using my the Amazon Route 53 for. And then I have the information flowing through a CloudFront. The CloudFront will act as a service that will enable me to deliver static and dynamic content. From there, the information again, instead of going straight to an instance where the WordPress site can be deployed, I would first actually have an internet gateway that will help me to provide communications between my VPC and internet. So even though it's not stated in the problem statement, I'm trying to make sure my security box is ticked off, making sure that the application instances or the data instances are not readily available and they are placed in a private subnet. And instead of accessing them directly, I'll have a public subnet where I have an ad gateway that can actually be linked to an application load balancer. The application load balancer will actually drive the traffic between the EC2 instances where I'm using in between an auto scaling group. So that will help me to scale my instances as the demand grows. Now, what I'll do is first I'll run an EC2 instance, will install my WordPress, latest WordPress, Apache server, PHP 7, OP cache, build an AMI, which I'll later use for any auto scaling group launch configuration to launch any new instances. Let's assume here the database access patterns are read heavy. Now, so I'll use a WordPress plugin that takes advantage of a caching layer like Elasticache, where the DB layer, Elasticache caches the DB layer, the frequently accessed data. Now, for database, because I want to pick my performance, I'll choose the highest performing one, which is the Amazon Aurora with MySQL compatibility. Now, once I have my database sorted, now I want to share commonly accessed data or store that information on Elastic file system. And for that, what I'll use is EFS mount targets on my that can be accessed by my EC2 instances. Now, once my EFS is set up, I'll be able to store information like share that can be shared like unstructured data like PHP files, config files, themes, WordPress plugins, so and so. Now, that's I think are covering most of the things apart from maybe maintainability and operability, right? Even for recoverability, like let's say I have a master and a read replica here, right? I can make sure like if my master goes down for any reason, my read replica can be made a master. Now, on top, or I also have a multi-region. So if one region goes down, I have another region with the same similar setup that can actually take over or recover from any faults. Now, if I want to explore this further, even though it's not added in this architecture diagram, I want to explore this further where my maintainability and operability boxes are ticked off. I can introduce Docker containers like in ECS Fargate cluster, where it helps me reduce maintenance activities, creating deployment workflows using pipelines. So it makes my life easy. So it's more easily operable. So those are the things I think, like, you know, when you're building your architecture, you can look at like scalability. Yes, it's being ticked off. And because of scalability, I'm choosing these. I'm choosing a multi-region instead of going with a single region. I'm choosing multi-AZ instead of going with single AZ. So those are the things which will actually let you make the decisions on how you want to have your system constructed. That basically ends my case study. I'll now, before I open the floor for any questions, I first want to thank you all for joining this and for the opportunity